Hi everyone, I am Sam. Today we are going to talk about time travel. Time travel, at its core, refers to the hypothetical movement of a person or object from one point in time to another, leaping into the past or the future as easily as we move through space. It's the idea that the flow of time, usually seen as an unbreakable forward progression, might not be as rigid as we once believed. In stories and theories about time travel, people explore unknown eras, witness major historical events firsthand, or glimpse what has yet to happen. This tantalizing concept has captured imaginations for centuries, sparking debates among philosophers, writers, and scientists alike. The allure of time travel goes back much further than our modern science fiction novels or blockbuster films. Ancient myths often featured characters experiencing some form of temporal dislocation, like sleeping for centuries, or journeying to mystical realms where time flowed differently. But it wasn't until we began to better understand physics that the notion of physically relocating oneself in time came into slightly clearer focus. For a long while, we saw time as something constant, something that ticked by at the same rate for everyone. It seemed like a relentless parade of seconds marching onward with no room for turning back. Yet the pioneering physicists of the late 19th and early 20th centuries began discovering that time was surprisingly pliable. A significant turning point in our understanding occurred when Albert Einstein introduced his theory of special relativity in 1905. Suddenly, time wasn't just a lone dimension, but part of a four-dimensional fabric we call spacetime. Think of it as a quilt, where your movement in space affects how your passage through time is stitched. This was a radical thought. Traveling faster affects how quickly time passes for you relative to someone else standing still. While it might be tricky to imagine daily situations resembling near light-speed travel, you can liken it to how a jet-lagged passenger experiences time differently from a neighbor who never left their hometown, only at an extreme cosmic level. Then came Einstein's General Relativity in 1915, further exploring how massive objects and gravity can curve this space-time fabric, influencing the rate at which time passes. Before anyone could blink, people started wondering if there were ways to manipulate these newfound insights and, in principle, slip through the timeline. But it wasn't just Einstein who fueled these dreams. Hermann Minkowski, Einstein's former math teacher, contributed by reimagining space and time as a unified continuum, like a stage on which the entire drama of the universe unfolds simultaneously. This understanding paved the way for science fiction writers to imagine wormholes, shortcut tunnels that might allow someone to jump across vast cosmic distances, or perhaps pop out at a different moment in time. Of course, not everyone agreed on how feasible such ideas might be, and plenty of controversies stirred. Early doubters felt the mere suggestion of backward time travel threatened the logical structure of cause and effect. How can you change something that's already happened? Could you, by stepping back in time, accidentally prevent your own existence? The grandfather paradox became a poster child for these debates, posing a dramatic scenario. If you traveled back and caused a situation where your grandfather never met your grandmother, would you simply cease to exist? People in lecture halls would ponder such riddles, and late-night debates between physicists would run around in logical circles. Writers seized on these paradoxes, weaving elaborate plots involving heroes altering destinies or repairing the timeline. Meanwhile, real scientists continued exploring the deep laws of the universe, inching step by step toward clarity. For instance, solutions to Einstein's field equations in certain configurations seemed to describe spacetime geometries that permitted closed time-like curves, essentially paths that loop back on themselves in time. When the mathematician Kurt Gödel found such solutions, it sent ripples through the scientific world, prompting heated discussions over whether these were mathematical curiosities or genuine glimpses at the loopholes that might allow backward time travel. Around the mid-20th century, as nuclear physics and quantum mechanics opened new doors, fresh perspectives on time emerged. The bizarre realm of quantum theory, where particles can exist in multiple states at once, hinted that our classical views of past, present, and future might be incomplete. Suddenly, conversations about parallel universes or many worlds interpretations ignited imaginations even more. If the universe splits with every possible outcome, perhaps traveling to the past would simply shuttle you into another timeline, neatly dodging all those pesky paradoxes. Stephen Hawking joined the discussion, cautioning that if time travel were so easy, we should be overrun by tourists from the future by now. He half-jokingly suggested the chronology protection conjecture, an idea that the universe might forbid time travel to preserve the consistency of cause and effect. Hawking also famously hosted a party for time travelers, only announcing it after it happened. No one showed up. From an engineering standpoint, theories emerged about creating wormholes or Einstein-Rosen bridges. Think of a wormhole like a folded piece of paper with two distant points touching. Instead of traveling across the entire page, you could step directly from one point to the other. This analogy is often illustrated by drawing dots on opposite edges of a sheet and then folding it so the dots align. The big catch is that stabilizing a wormhole would require exotic matter with negative energy density, something we're not sure is even available in the quantities needed. Still, physicist Kip Thorne and others have investigated how gravity and exotic matter might, in theory, maintain these openings. It remains an open question whether advanced civilizations might harness such bizarre materials to build a genuine time machine. In the midst of these debates, we see one recurring theme: collaboration alongside fierce disagreement. Physicists gather at conferences to present new mathematical models, only for others to poke holes in them. Journals publish new theories, fueling rows between old-school traditionalists who see time as sacrosanct and adventurous theorists who argue that if mathematics allows it, we should keep looking for ways to make it happen. In the background, philosophers weigh in, questioning the very nature of reality and our perception of the temporal order. The back and forth can be as dramatic as any soap opera, just that the dialogue is full of references to black holes and reference frames. One everyday comparison to grasp these ideas involves thinking about how we sometimes measure distances. If you're driving through mountains, an incredibly winding road might require you to travel dozens of miles to reach a point that's directly only a few miles away. In time travel discussions, these mountains are like immense gravitational wells or extreme distortions of space-time. A shortcut or tunnel, a wormhole, would be the improbable but intriguing route that bypasses the long journey. The question is whether Mother Nature has built roadblocks making this route impossible, or if there is a hidden path we just haven't discovered. Despite being drawn into technical complexities, it's crucial to remember the human spirit behind these investigations. The possibility of controlling our movement through time is so enticing that entire research careers have been built on calculating probabilities, writing equations, and debating intricacies of cosmic geometry. Moreover, many of these scientists were once kids who stared at the stars and wondered if they could hop into a time machine to see dinosaurs or meet Shakespeare. That sense of wonder never fully fades. Even amid complicated equations, there's a childlike fascination that drives people to keep seeking answers. Looking forward, the story of time travel is still very much unfinished. Current technology doesn't allow anything beyond small effects like time dilation for astronauts traveling at high speeds or orbiting in stronger gravitational fields. Yes, technically they do time travel a tiny bit compared to people on Earth, but it's a fraction of a second difference, and it certainly doesn't look like Hollywood's dramatic leaps. In labs, we can manipulate tiny particles to behave in peculiar ways that hint at deeper truths about time and space. But harnessing those effects to send a person to the 15th century or the 25th remains squarely in the realm of speculation. Nonetheless, the journey so far has taught us a lot. We found that time itself is more flexible and extraordinary than day-to-day experience suggests. We've learned that scientific progress often comes from pushing the boundaries of what we think is possible, then letting curiosity guide us to test those boundaries. The controversies, the paradoxes, and the philosophical conundrums are not mere distractions. They serve as catalysts that refine our understanding of reality. In a way, the entire conversation about time travel is a testament to human creativity and our drive to explore. As we reflect on how far we've come since Einstein scribbled his mind-bending equations, it's clear that our knowledge is still incomplete. Researchers continue wrestling with new data from gravitational wave observatories and cutting-edge particle accelerators. Each discovery might eventually help us piece together a more definitive picture of how time works. Perhaps we'll discover new dimensions, or confirm that wormholes can exist, but are too tiny or brief to be of any practical use. Maybe we'll find that nature has hidden time travel behind cosmic no trespassing signs, protecting causality at all costs. Or maybe, just maybe, one bold theory will turn out to be correct, and future engineers will open the first official time port. Until then, the notion of time travel remains one of the most fascinating frontiers at the intersection of science, philosophy, and imagination. It sparks our desire to see lost eras or see how humanity will evolve in centuries to come. It dares us to wonder if we have the right tools, even the right mindset, to uncover the secrets of time. Most importantly, it reminds us that no matter how certain we are about our universe, there's always more to learn. Embrace that uncertainty, keep asking questions, and who knows, maybe one day you'll receive an invitation to a party that happened long before you were born. After all, the story of time travel is still unfolding, and each of us might play a part in writing its next chapter. That's it for today, and I'll see you in the next episode.